Okay, so in this section, objective, we're dealing with multiplying and dividing radical expressions. We got to be careful with a few things that we need to pay attention to here when we're multiplying and dividing radical expressions. So if you missed the notes, let's go ahead and take a look at a few things I wrote and make sure you remember this rules and definitions. So take a look at over here. Whenever we are multiplying radicals, okay, I don't know if you wrote this in your notes or not, but whenever I'm multiplying radicals and I have a certain root, certain index, the index must be the same, okay, for us to be able to multiply. If I have a square root, it must be a square root here. If this is a cube root, it better be a cube root as well. So the index must be the same. The radicand, as you can see, I wrote A and B, two different letters. So the radicand does not have to be the same. So I can multiply a 2 times a 5 or a 4 times a 16. It really doesn't matter what the radicands are. But the index must be the same. That's why I wrote here, n must be the same. And then we can just multiply the radicands, okay, if the index are the same. When it comes to division, if we have a n root of something divided by the n root of something else, because the indexes are the same, we can have a similar expression under the same index radical. The radical with the same index can go, the rational can go under the same radical. So, and it's also true that if I have this situation right here, if I have the square root of a rational, I can also go and split them into two. The numerator gets its own and the denominator gets its own radical. I love this rules of exponents and rules of radicals because they are true in both directions. So it is true for you to go from here to here, but it's also true for you to go from here to here. Okay? The converse is true in both ways. It is true for you to combine under one radical, but it's also true that you can split and have two different, a radical for each of the numerator and denominator, as long as the indexes are the same, okay? As long as the indexes are the same. Whenever we are dealing with multiplying and division, especially division over here, we want to make sure that we rationalize the denominator. We don't want to leave an answer, a simplified answer with the radical and the denominator. We want to go ahead and finish getting rid of that radical. Also, it would be very, very, very helpful if you could create for yourself just a little flashcard with your perfect squares and perfect cubes. I like to always have it, I mean, the first perfect squares, 1 through 100, we pretty much have it memorized. But cubes is one of them that we tend to forget very often. Okay, 1 cubed is 1, 2 cubed is 8, okay, and you keep on going. 3 cubed is 27. We usually memorize the first 3, and then we start forgetting the rest. So it's good for us to just have it in hand because we'll be using that a lot. As you can see, I didn't even finish it because we're most likely not going to be using ginormous cube numbers. But it's always good to have little perfect squares and perfect cubes because we're going to be constantly using them here with the multiplication and division. Okay? So let's do a few examples here that I have before we move on to anything here on your worksheet. So let's go ahead and do number 5. Number 5, when it comes to multiplying here, we have cube root of 4 times the cube root of 16. So the indexes are the same. That is the very important thing I need to deal with. The indexes are the same. So I can go ahead and multiply inside of the radicals, which are the radicands. And I would end up with the cube root of 4 times 16, which is the cube root of, I like to see this, it is 64, but if you want to see, this is 4 times 16 is 4 times 4. Because I'm dealing with the cube root, do you see that we have a set of 3? 4 times 4 times 4 is 64. So the cube root of 64 is just 4. Okay, so this is what equals here. The answer is 4. Again, this is the cube root, so we really don't need to worry about absolute values, and this is not a variable anyway, so we don't need to worry about absolute values at all. Okay, let's take a look at over here. We're dealing with square roots. I have a nice little invisible number 2 here on both radicals. So we have a square root of 8x and the square root of 6xy squared. We are multiplying them. So we carefully pay attention to the rules we have here. When we multiply, we make sure that we have the same index. And then we just multiply the radicals. Some people like to simplify it before they multiply it, and that is okay with me. Some people see that this is 2 times 4 times x. Absolutely. If you want to go ahead and simplify it, that is totally okay with me. I can take the square root of 4. The square root of 4 is 2. But this other 2 over here, these other 2 values needs to remain inside. So that would be 2x. Okay? So we simplified here before we're even multiplying it. I'm okay with that. 6, we cannot take the square root of 6, and that would be 2 times 3. There's really nothing to simplify. X, we don't have enough to take it out, but we sure can take the square root of y squared. We have an even, and it's going to come out with 2 divided by 2 is y, and inside we're going to have 6x. Even, odd, we got to put the absolute value there. Okay? So now I can multiply outside terms, which are our coefficients. We can multiply them together. 2 times the absolute value of y. And the radicands, we can multiply it together. We have 2 times 6, which is 12, and x times x, which is x squared. When you get to this point, you look at it and you say, oh, I still can simplify it some more. So we can definitely take the square root of 12, which is 4 times 3. I can take the square root of 4, which will be 2 times the absolute value of y. Let me open it and take things out. 2 times the square root of 4 is 2, but this 3 is going to have to stay inside. And the square root of x squared, 2 divided by 2, is 1. And there's the inside is the cube, the square root of 3 has to stay inside. Okay? So now we can go ahead and multiply whatever's left over. 2 times 2 is 4. We have an x, and we have the absolute value of y, and we have the square root of 3. Now, if that is the route you chose to do it, I did it like you, and you're looking at this x saying, do we need absolute value? We don't, because we go back to the original case and we see that the x had an odd exponent anyway, so we don't need an absolute value for the x. Some people chose it to do it differently. They said, you know what, I want to multiply everything inside, then go ahead and, so there's this other version over here if you chose it to do it a little bit differently. If you say, I want to go ahead and put it all under the radical. So the square root of 8 times 6, it's 48, and then x times x is x squared, and then y squared. So if someone chose to do it that way, that is okay as well, okay? So, and then you can simplify it, and you're going to end up getting exactly the same answer as us, which is 4 times x times the absolute value of y, and the square root of 3, okay? So you would get exactly the same answer, I guarantee you, if you multiply them all. Remember, to decide about absolute value, we have to go back to the original case to decide about absolute value. Even for the index, odd for the exponent of x, so x does not get an absolute value. Even for the index, even for the exponent of y, so y needed the absolute value because you end up with odd. Okay? So that is either way, if you chose it to take things out and then multiply and simplify, or if you decided to just do it at once, to me either way works. Okay? Let's go ahead and do one more. I have over here a much more complicated one, which is number 13. Okay, so we have values outside. These are our coefficients. We multiply coefficients times coefficients, and then radicans times radicans. So let's go ahead and take care of the outside terms. We have an x. First of all, take a look at the indexes. They are the same, so we're good. So coefficient x times this coefficient right here, 2x, we have 2x squared, okay? I just multiply the outside terms, values, which is 2x squared. Now, if you want to go ahead and combine all under to make sure that it stays, and then from there simplify, that's okay. So I have the cube root of, I have 27, and I have an x squared times an x cubed. That would be x to the 5th, because we add the exponents. And then we have a y. Okay, so I multiplied the radicans times the radicans. 27 times 1, x squared times x cubed, and y by itself. Now I have the outside, the coefficient right here is 2x squared. Let's see if we can take the cube root of anything that is inside. The cube root of 27, it's 3. And x to the 5th is not divisible by 3, but we can rewrite it as x cubed times x squared. We can definitely take the cube root of x cubed. The cube root of x cubed is x, but of the x squared we have to keep it inside. So I'm going to write the cube root of x squared. And y, there's not enough y's. We would have to have a set of 3 y's to be able to take the cube root. So we don't have it. That has to also stay inside. So I'm going to put it right here. So now I can just go ahead and multiply the outside terms here. 2 times 3 is 6. X squared times an x is x cubed. And then we have the cube root of x squared y. We don't need to worry about absolute values because we had a odd index. So here's your final answer. And let's move on to another problem. Notice that I always write the cube, it's cube root. You need to make sure that you keep writing cube root throughout. Don't forget to write that is a cube root. Don't turn a cube root into a square root, okay? Okay. Now right here, number 15, we have index of 2, invisible 2. This is also invisible 2, so our indexes are the same. We don't have anything outside. I would consider invisible 1 times an invisible 1, which is just a 1. So I can go ahead and combine all under one radical. That would be the square root of 2 times 3 is 6. X to the 1st power times x cubed would be x to the 4th. Y to the 1st power times y to the 5th would be y to the 6th power, because we add the exponents. We're dealing with the invisible 2 here, which is a square root. The square root of 6, we cannot take the square root of 6. Remember, perfect squares are 1, 4, 9, and so forth. So that 6 I cannot take the square root of, but I can definitely take the square root of x to the 4th. 4 divided by 2 would be a 2. And 6 divided by 2 would be y cubed. The only thing I couldn't take the square root of was the square root of 6. Okay? I don't have to write the square, but there we go, the square root of 6. Now let's take a look if any of these guys need absolute values. Over here, we always go back to the original. Okay? Check the original. Check the original problem to see if you need absolute values. So the x here was odd. Automatically, I don't need absolute value for it. Okay, over here was odd as well. The y's was also odd exponents, so we don't need absolute value at all. Remember, the rule is even index, even exponent, and then end up with an odd, which we didn't even end up with an odd for the x, and it didn't pass the rule up here. So our final answer here is done. Okay? All right, so let me see if I have one more problem for us to practice. I do, right here. Number 18. Let's see if we're multiplying them correctly. The outside values, outside of the radical, I have a negative here. That means I have a negative 1. It's just not written, and 1s are not written when it's in multiplication. Okay? So I have a negative 1 times a 4. That is a negative 4. Okay, negative 1 times this 4 is negative 4. I have cube root and cube root, so I'm going to combine them all under a cube root. I have 2 times 12, which is 36. Okay, 2 times 12 is 36. I have x cubed times x to the 5th. There's a rule of exponent that says when we have the same base, we may add the exponent. That would be x to the 8th power. Y's, I have a y here, same base, y times y. Squared and a 1 here, I would add up and I would get y cubed. 2 plus 1 is 3. Alright, so let's go ahead and see if we can take the cube root. It's not a square root. I know you see a 36 and you say, oh, the square root of 36 is 6. We're not looking for square, we're looking for cube. Okay? If you need to break this 36 down, some people get like, oh, I don't know what to do with cube roots. Well, there's 2 options. You can take a look at your little list you made, or you can break this down and see if you can find sets of 3. I was telling my students that when I was tutoring one of my students said, you know, don't panic. Break it down as this is 2 times 18. And then you break it down and you get 2 times 9, right? That's what 36 is. And you break it down and you say 2 times, I'm sorry, this is 3 times 3. So you're looking for sets of 3. So 2 times 18 is 36. 2 times 9 is 18. But this is 3 times 3. So there's really not anything that would become a set of 3 here. Maybe you should, maybe this is 3 times 12. You can see, oh, I see that this is 3 times 12. But 12 is 3 times 4, and then 4 is 2 times 2. So it doesn't matter how you do it, you're not going to see a set of 3. I see a set of 2, but we're not taking the square root. We're taking the cube root. Okay? So there's nothing I can do with 36. So negative 4 is going to stay. I'm going to try to take cube root of certain things. I definitely cannot take the cube root of 36. That's going to have to stay inside. And the 8 is not divisible by 3. But we can go ahead and write that differently, right? We can write as x to the 6th times x squared. The 6 is divisible by 3. 6 divided by 3 is 2. But this one is going to have to stay inside as x squared. And the 3 is divisible by 3. The exponent of 3 is divisible by 3. So we get y to the 1st power. 3 divided by 3 is 1. So I simplify to the best I could. This is going to be a negative 4 x squared y times the cube root. Please don't forget to write your cube root of 36 x squared. It looks so tempting to take the 6, the square root of 36, but that's not what we're doing. We're doing cube roots. Okay? So there is our final answer. No radical need, no absolute value needed because we're doing cube roots, not even roots. So we're done. All right? My last example here, I saved it for last, was something a little bit different. We did it. It's multiplying a radical times, we have a binomial. We have 2 terms here. It's the same rule. We have index of 2, index of 2, and index of 2. We can multiply this. 6, the square root of 6 times the square root of 6. We multiply the inside, the radicands. 6 times 6 is 36. Plus, and then we have the square root of 6 times the square root of 18, which is that 100 and what is it? 6 times 8 is 48. That's 108, right? So we have 108 there, and now we can go ahead and see if we can simplify anything. I don't know if we can, but let's try to look for perfect squares. The square root of 36 is 6 plus, let's take a look at 108. Let's see if we can take anything out. So when I take a look at 108, I'm looking for perfect squares. I wonder if this is divisible by 36. If you check your calculator, see if his 108 is divisible by 36. I'm just looking at perfect square numbers like 25, 16, 36. If you divide 108 by 36, 36 times 3, that does work, doesn't it? 108 divided by 36, it gives you a 3. That does work. So this is the same as 36 times 3. We can go ahead and take the square root of 36, which is a 6, but we cannot take the square root of 3, so we keep it the square root of 3. So this actually simplifies it to 6 plus 6 root 3. Okay? That's all it is. We multiplied it, and then we try to simplify it. Do not add a whole number 6 plus a 6 root 3. Okay? We cannot add this yet because we have this multiplication here of 6 times the square root of 3. This is as simple as it's going to be without using calculator. Okay? 6 plus 6 root 3. We don't add them up. Okay? It's kind of like trying to convince you of that. It's kind of like you're trying to add 6 plus 6x. They don't add up together. Okay? You have a variable here. We don't know what it is. In this case, this is the simplified form we want. That's good enough for us. Okay? So, and that is how you multiply things. Be careful when you're multiplying. Don't panic when you have big numbers to start breaking them down, factoring them out. See if you can find sets of 2s or 3s, whatever you're looking for. Okay? And that's how you multiply radicals. Good luck.